All right, welcome back to our chapter 15. This chapter is based on quantity of heat, heat capacity, and latent heat. So let's run. Uh, this one has number one has to do with calculation. Number two, uh, let's see. Okay, number two, similar thing. Similar thing. Number three, the following are some units. The following are some units. So we're giving unit here. Newton seconds, Newton per seconds, Newton per meter square. Joule, this one is called Joule per Kelvin. J raised to the power of 0, K raised to the power of -1. This one is called Joule per kilogram. What are the units of the latent heat? What are the units of the latent heat? The unit of latent heat is V, this one, Joule per Kelvin. Number 4, the amount of heat required to raise the temperature of a body is, the amount of heat required to raise the entire temperature of a body is called thermal capacity. 30, all the heat generated, 6, number 5, number 6. Number 7, the latent heat of fusion of a substance is the heat required to, the latent heat of fusion of a substance is the heat required to change the unit mass of the substance from solid to liquid at a constant temperature. 7 is option C. 8. When equal weight of iron and water are subjected to an equal supply of heat, it is found that the piece of iron becomes much hotter than that of water after a shorter time. This is because... Alright, so number 7 is change unit mass of a substance from solid to liquid at a constant temperature. 8. When equal weight of iron and water are subjected to an equal supply of heat, it is found that the piece of iron becomes much hotter than that of water after a shorter time, because the reason is because the specific heat of water is higher than that of iron. D. 9, 10 would run really fast. 15, 16. The specific latent heat of fusion of lead is the amount of heat required to, the specific latent heat of fusion of lead is the amount of heat that's required to change the state of unit mass of the lead at its melting point. Latent heat of fusion is the specific latent heat of fusion of lead is the amount of heat required to change the state of a unit mass lead at its melting point. Option C. 7 has to do with a bit of calculation. Water added to this time of its mass, 17, 8, 17, 21, 22, 23, 21, 22, 23. Next, okay, this ones they have to do with calculations. A lot of the questions here are calculation based. Alright, 30. This chapter has a lot of calculation. A quantity of ice at -10 degrees Celsius is heated until the temperature of the heating vessel is 90 degrees Celsius. Which of the following constant is not required to the vessel? 33. Which of the following constant is not required? Specific latent heat of vaporization. See, they say a quantity of ice, you heat them until the temperature of the heating vessel is 90 degrees Celsius. Which of the following constant is not required to the vessel? Specific latent heat of vaporization. Because when you get ice, if you heat ice, it go melt to water. That one has specific latent heat of fusion. But when you heat water, it can't change to vapor. That one has specific latent heat of vaporization. So option D is not involved. Number 34. Equal mass of copper and rubber are raised to the same temperature. After some time, the copper was observed to be at a lower temperature because the copper will be at a lower temperature. This is because the specific heat capacity of copper is lower than that of rubber. 35, 36, 37. What happens when a certain quantity of a pure ice is completely changed to water at 0 degrees Celsius? Ice is changed to water. This one has to do with specific latent heat of fusion. You see, 37. Latent heat is absorbed, the mass remains constant and the volume decreases. Latent heat is absorbed, the mass will remain constant and the volume decreases. Option A. 38 has to do with calculation. 39, 40, 41, 44 has to do with calculations. Let's go. 44 calculations. 40 calculations. Okay. 46. A drop of petrol makes a finger colder than a drop of water would be because the petrol takes its latent heat of fusion from the finger. That's not it. The petrol vaporization rather. The petrol takes its latent heat of vaporization from the finger. Option B. Don't forget, vaporization are when the liquid changes to gas. So fusion are when the solid melts to become liquid. 49, 50, 51, 55. The quantity of heat needed to raise the temperature of a body by 1 Kelvin is the body's just by 1 Kelvin is the body's heat capacity. Definitely option D. They say that is required to raise the body by 1 Kelvin is the body's heat capacity. 58. The quantity of heat required to raise the temperature of a body to raise the temperature of unit mass of a substance through unit temperature is, this one will be specific. 58 is option A, specific heat capacity. When you hear unit mass, unit temperature, specific heat capacity. But when you hear to raise the body temperature, it's just the heat capacity. Okay, 58, 9, 60, 61, 2 has to do with calculation. And that's where we'll draw the curtain for this chapter. This chapter has a lot of calculation questions compared to the theory. There's a series for the calculation that will also be delivered to you. Please do not run classes if you like to be part of the class. If this is your first time coming across our video, I'll drop the link to our group in the description section of this video. While going through this, I expect you to jot down just a few points. The points here are not that much. Jot them down, snap and send to us on the group. If you also have a question, you could drop it in the comment section for us to take. Thanks for watching. I'll see you in the next video.